lab. And also we have Niger at Orissa for physics, chemistry, I think bio, and we have many other organizations. Everywhere in BSc, we have different groups. This chemistry, radiochemistry, I belong to nuclear fuel, materials, nuclear science, bioscience. All I belong to engineering. We have radiation photochemistry, theoretical chemistry, chemistry. We have control water, steam chemistry, and we have Center for Characterization of Materials. This is in Hyderabad. We have facility of Apsara, we have Duba, we have water laboratory, we have HRP center, SDI. We have our reactors. This is stock, first reactor, Cyrus stock, Duba is working, Camel is working. Now Apsara has come as a new reactor. In BSc, we have facility of neutron first reactor. Here is inside the reactor. How a reactor looks like. Here is the fuel and other things. And side there are scattering chambers. Neutron scattering, diffraction scattering, PGNA, all the studies, smaller neutron scattering, it is inside the reactor. And these are the beam lines, neutron guide. Here light tube, you have the source, the different sources like you have XRD, we have neutron diffraction also. We have accelerators, as I have shown you, TIF, we have in Delhi also, IUSC, National Science Center, IUSC, Calcutta, Institute of Physics, we have at Northcote, and we have CCC in Hyderabad, low energy and high energy accelerators for nuclear physics and nuclear analytical research. The facilities which I am working, or I was working, these facilities are our development at BSc, Druva PCM pneumatic carrier, new Apsara, PGNA, what I work at Druva. This is facility started in 2010, PG, PIG at BSc. We have an external, you can do sample directly. We have developed a method to do work in 2 to 5 minutes, sample is returned with a powder and binder. This year given 10 to 20 papers, and this technology has commercialized so that money can be generated from this work. We have different research in nuclear analytical, as I told you. All area you think of as a research, you can do a nuclear analytical or studies of analytical. If you do nuclear analytical, you can do nuclear activation matter composition, ion and pixie picky. You can do many samples. Think of a sample that can be analyzed for chemical characterization. But the most important is you want high accuracy, high precision. At the same time, you want sample to be returned, sample to be non-destructive, not to be radioactive, no waste, no radioactive. That is possible by pixie picking. Okay? So this technique is now compatible with TIMS. 411. TIMS is high precision, but destructive. We have developed a method, no destructive, direct sample. So it is a competing. Now there is a PG versus TIMS going on. TIMS machinery 5 to 10 crore. PG is only 50 lakh detector and facility. So that's why this technique is now commercial. It is going very huge. Nuclear power corporation boron is getting certified by DRC. So that is our development of work. You have seen the elements by Na. You have ion beam. You have many research. PG, PG, RBS, LRA. You have our accelerator where we are getting. We have the scattering chamber, we have a lithium PN, we have pixie facility like IOP, we have in BRC. We can do many elements like Na, but sensitivity wise may not be that great like Na. But some elements having a higher X-ray yield can be done better, like iron, nickel, copper, etc. can be done better by pixie. But no other element cannot be done by pixie. PG, so we do PG, you can see fluorine, boron, isotopic, lithium, many elements that cannot be done in glass, ceramic, alloy, oxide, otherwise, without destruction, we can do the elements. This is our own R&D. PS has developed many technologies for clean drinking. So you can go to DRC, TPCD, Technology Transfer and Collaboration Division. Right on TPCD, DRC technology for public. So there you can get how to get DRC technology. There are water purification system, and they also measure arsenic, chlorine, iron, uranium, many things they can do in that. We have chloride kit, arsenic kit, chromium, uranium, iodine, selenium. We have different methods for certifying the food, water system at the DRC. We have isotope hydrology like water. Water will be a big problem in future. Like energy crisis nowadays now water. So water storage, water harvesting, water recharging is very important. The cities like Bangalore, which was the most favored city, will be least favored city in few years. Because of the urbanization, because of the road, because of other things, water seepage is not there. So Bangalore is going to really face a lot of problem on water. So there is a work going on by different technical recharge. So that you have soil, there are different techniques. Many NGOs are working in Bangalore to have water application. So water recharging, reduction application industry, and electronic applications. So mainly our focus is on Delhi, Bangalore, not the Calcutta, Delhi, Bangalore mainly is now water scarcity and problem solving. TIFR, you know, many facilities. You can see the facility at TIFR. We have given physics, I think, the best accelerator peloton in India, which is highly utilized, high efficient, is TIFR. No comparison. The system is so good, experimenter gets the room. They provide many things to do the experiment. They provide the facility. Many cases we don't have facility, we give the beam. Okay? So TIFR is the best laboratory in our India for nuclear physics, other works, radioisotope. There are collaboration DRC, TIFR, ISRO, DRDO, many universities. They have very good facility. Everyone should visit TIFR Mumbai to see how the facility is there. And it was built by none other than Umibaba. In 1940 it started. Best collaboration. All the beams are available. How big facilities are in TIFR? Just see. All mega facilities with high cost value. And the environment is so good. We get one SPG, Indian National Gamma, so many SPG having so much money for good research. We have facility for material characterization, pore volume, pore size, porosity, depth dependent defects. Many things are there in DRC. The project analysis spectroscopy at DRC. We take a sodium 22 source for positron. We have good facility for electron resonance spectroscopy. We have good facility for mass spectrometry. These are all open for research, free of cost. We have good facility in materials group. All the facilities, same Chem, many facilities including electron microscope technique. We have got at DRC. There is a new technique called atom probe technique. It can give 0.1% I think the sensitivity. And this is a very good depth dependent. Like alloys, other things, you can get the rough value of the elements. Presently, as you know, gamma sources needs air pollution for shielding and radioactivity. You know, gamma source is helping for healthcare, again for radiography of material. Nowadays, electron beam is coming very big way. Electron beam is switched on and off. When you need to switch off, when you do not need switch off. So less radioactivity. So electron beam can do similar work like gamma. You can do semiconductor waste, corrosion, gemstone, material science. Gemstone, permanent corrosion by neutron, but its activity. But by electron beam, gamma, reflector is very good. Many things can be done by electron beam. You can see here facility at Mumbai in the center. Collaborations are many. Very good thing. Even irradiation processing, quarantining, everything possible to limit the energy and do it. You can do tomography. This is real, this is photo, this is a photo. Just see, this is real, this is photo. Can be done by transfusion method of red solar radiation. So this is the facility open in 2021 where I am working as a task force member, scattering, linear facility, OTR for ion beam, electron beam, neutron radiation probe, all nuclear article I presented for you. Everything is available for research within the and university. All the institute can collaborate. Material science. This you can take a photo. This day to the faculty. These are the persons to contact. He is the center director. We are the person who are helping you this. So I am there and other persons are there. You contact us. You will be helpful for your DAD and other things. We will be helpful for giving facility. And without project, with project. Here I can tell you, without project, one time visit can get TADA and accommodation can be given, but train pay for university people. But if you have project, 3 years you can travel, they give you TADA and accommodation. Without project, you can do. That's my point. If the facility can go to UGC, user portal, facilities, look for national BS facilities. We have contributed, we have uploaded what are the facility available, who should be contacted. Please look at it and directly write and you can cover one. This is the site. This is user portal. Here is clearly facility accessible to users. There we have already given. I have already given this name. Very simple, you write the contact scientist, write to center director, then we will help you how to come, how to work, how to stay, when you can come. You can scattering, you can beam, you can material material science, you can radiation, everything possible without any cost. Accordingly. But for conference, funding, fellowship, you have to apply ARS, this project with instruments. In UGC you can use our facility, but in VRMS you can buy instrument, you can collaborate from DE. It can be IOP, LISM, CCCM, DCC, Photogram or DSC. You can do. Also, like this meeting you will get funding. You can apply, that's called partial funding, but DSC or DE person as well. So, funding you will get. A student can join the project, fellow can join for PhD. They get UGC salary without having a registration. That is called VRMS project. How to join after BTech MSc? You can get an officer. You go to website of DA, DRC recruitment. Everything is available. Nowadays for PhD it is there, for job also it is there. You can get all guidance. 125 students per year we are taking chemistry, physics and bio. It's not easy, but there is a fellow. But for job you can get things. After BSc, you can get a category 1 or scientific assistant, also you can do PhD. This is a summary how to join BSc DA. Everything, you can go to website, you can get BSc, MSc, BTech, MTech. After PhD, you can get RA. For 2 years, you can go to upload or somewhere. All the facilities are there, all the institutes are there, way how to take guidance. Okay? You need a contact scientist right there. Then go to website and guide you. There are websites you can get. Again, available for all. Thank you.
I would now like to request Dr. Sujit Kumar Devari sir, Assistant Professor in Chemistry, HOD of Department of Chemistry, to give an appreciation to Dr. Raghunath Acharya sir for his talk.
So since no more questions from student side, so let me thank Dr. Acharya for his nice information regarding the career opportunities like research or for any job program in Department of Atomic Energy. So since there are various institutes of Department of Atomic Energy in our country, so please feel free to contact in those websites and the contact numbers. So it will be always helpful to you. Thank you, sir.
Thank you, sir, for delivering such a beautiful speech and having given all the session two, technical session two.
Actually, there was a quiz. We don't do the quiz now. We have to leave. We are not really mandatory. So all the best, sir, and all the students, faculties are there. Yeah. We will be in touch. We have already decided with the DC what to do. So it will continue. This is the start of the beginning. So we will continue. Thank you very much.
Students, now there is some time, little bit time is there. So I will show you one video related to the BRC, atomic research and all the things. So just see the video, learn something from that video, right?
Launch for us.
टीवी हमके सुनने जाए एक्चुअली ये प्रोग्राम कॉलेज का
हम वो वीडियो
अरे जे যে পাখি রেকর্ড করেছে ঠিক পাখি রেকর্ড
जस्ट सी कौन अच्छी से हम देखिए वीडियो है बहुत गुणे जिन जानवा ପାଇଁ ଅଛି वीडियोटा रिलेटेड टू डीआरसी आउ तार केमती स्टार्ट ହେଲା केमती कोन हेची आगु केमती रिसर्च आछि बी सॉरी डी हां तो मु ऑन करू छी आपण देखिए
India attained independence on August 15, 1947, after a prolonged struggle for self-rule. Much has been accomplished in the long march since her rebirth. The country having risen to become one of the largest economies of the world today. Science and technology have played a pivotal role behind every facet of growth and transformation of the nation over the last 75 years. Catalyzed by R&D efforts of many organizations which have been established over the decades. Department of Atomic Energy, or DAE, is one of the prominent departments which has made significant contributions. The Atomic Energy Commission was constituted in 1948, soon after independence, and the DAE was established in 1954. Thus began India's journey in harnessing atomic energy for peaceful purposes under the far-sighted leadership of Dr. Homi Jahangir Bhabha, the great scientist and visionary. Elected president of the first international conference on peaceful uses of atomic energy at Geneva in 1955, Dr. Bhabha played an important role in creating awareness and fast-tracking the use of atomic energy for peaceful purposes all over the world.
The immense concentration of atomic energy has made possible other developments whose immediate results have been less happy and which have placed a pall of fear over the peoples of the world. A widespread atomic power industry in the world will necessitate an international society in which the major states have agreed to maintain peace.
Dr. Vikram Sarabhai, who took over the reins of DAE after Dr. Bhabha, was an able and dynamic successor. He continued to carry forward and expand the atomic energy programs of the nation to greater heights. Activities in India started in earnest with the setting up of Apsara, the first research reactor of Asia at the Atomic Energy Establishment, Trombay, which is now known as the Bhabha Atomic Research Center, or BARC. A second 40-megawatt research reactor Science was commissioned in 1960, followed by a 100 megawatt research reactor, Dhruva, in 1983, and a recently built Apsara U reactor in 2018. Radioisotopes produced in these research reactors play a key role in the development of applications related to radiation technology, such as in healthcare, agriculture, food preservation, and several other societal programs of DAE. Associated activities such as uranium mining, refining, fuel fabrication, fuel reprocessing, and waste management were commenced in parallel at BARC and other locations for sustaining the research reactor and power reactor programs. DAE also embarked on R&D programs in numerous disciplines, carried out primarily at BARC Mumbai, which is the mother institute of DAE. This large integrated center supports research activities in multiple domains, such as physics, chemistry, biology, material science, electronics, etc. Nuclear power generation in the country commenced with the setting up of 2 power reactors at Tarapur, Maharashtra in 1969. Nuclear Power Corporation of India Limited has the comprehensive capability to design, construct, commission and operate nuclear power plants. 22 nuclear power plants are currently operational in India. A state-of-the-art, fully indigenous 700 megawatt electric reactor at Kakrapar, Gujarat has recently been connected to power grid. It incorporates enhanced safety features typical of Generation 3 plus reactors. The department comprises of several institutions which harness the power of atom and contribute to nation building. Atomics Minerals Division was constituted in 1949 to prospect and mine for uranium in the country. Nuclear Fuel Complex was set up in 1971 for manufacturing fuel for nuclear power plants. It is the largest integrated fuel manufacturing facility at a single location anywhere in the world, with a capacity of 1,500 tons per year. Electronics Corporation of India Limited was established in 1967 to meet the needs for design and manufacture of highly complex and reliable instrumentation and control systems for nuclear reactors. Heavy Water Board came into existence in 1969 for the manufacture of heavy water required in pressurized heavy water reactors. Mangaluru Heavy Water Plant is today the largest heavy water manufacturing plant in the world. Indira Gandhi Center for Atomic Research was created in 1971 for research in fast breeder reactors. Raja Ramanna Center for Advanced Technology was born in 1984 for carrying out cutting-edge R&D in lasers and accelerators. Amongst the numerous societal applications, diagnosis and treatment of cancer is one of the most important wings of DAE operations. Tata Memorial Center, under the aegis of DAE, is a pioneer in cancer research and treatment in the country. About 500,000 patients, including thousands from outside the country, receive treatment every year at an economical cost. More than 240 hospitals across the country have been linked into a National Cancer Grid, or NCG, to share knowledge and resources for uniform and better treatment outcomes. One of the recent noteworthy contributions of DAE in cancer treatment is an eye plaque using radioactive ruthenium for treatment of ocular cancer. DAE formulates radiopharmaceuticals, coordinates clinical trials, creates harmonized protocols, and provides imaging services. Millions of procedures are carried out at DAE centers every year. DAE has an extensive program on mutation breeding for developing improved seeds for various crop varieties. 49 fungal crop varieties, including groundnut, rice, mustard, and pulses with improved characteristics like higher yield, early maturity, improved disease resistance, drought tolerance, etc. have been developed and are being cultivated extensively in the country. DAE has also developed irradiation technology for preservation of fruits, vegetables, pulses, spices, seafood, etc., which reduces wastage, thereby improving the viability, profitability, and availability of these products. Food preservation is also served by the liquid nitrogen-based reefer system developed by DAE for refrigerated transport of vegetables, fruits, seafood, etc. Technologies for smart cities, such as radiation-based sludge hygienization and sewage treatment, are also finding uses in large urban centers as eco-friendly and sustainable methods of urban waste treatment. The hygienized sludge, fortified with nutrients, makes extremely good manure and is marketed under the brand name BioGold. DAE is an active participant in several international mega science programs such as CERN, FAIR, ITER, LIGO, SKA, etc. A massive cryostat, which is the largest terrestrial vessel in the world, has been built and delivered to ITER in the recent past. DAE is a proactive partner of International Atomic Energy Agency in the area of research and training related to nuclear science and technology across the globe. India has also entered into civil nuclear cooperation agreements and regional cooperation agreements with several countries, with the objective of developing mutually beneficial scientific and technical cooperation for the peaceful uses of nuclear energy. Some noteworthy initiatives in this direction include exporting radioisotopes to partnering countries, providing indigenous radiotherapy equipment, Powertron, to partnering countries, bridging the global gaps in cancer care by launching the NCG Vishwa Cancer Care Connect, a linkage for sharing information, knowledge and expertise. Creating a dedicated center known as the Global Center for Nuclear Energy Partnership to promote collaborative research and training programs. With eyes firmly fixed on the future of the nation and indeed the entire humanity, DAE continues to strive towards extending the benefits of its expertise and knowledge in the true spirit of Vasudhaiva Kutumbakam. The world is one family.
Thank you for watching.
ଗାଡ଼ି ସାଇଡ଼୍ ନେଇଯାଏ ଏଠି ଅଛି ଯେଉଁଟା ଖାଲି ଅଛି ପାଣି ଗୋଟେ ଫୁଲ୍ ଅଛି ସବୁ
खाली बसिले
आ ही नहीं रहा भाई एंगल क्या बना प्राइवेट